this video, we are going to solve some problems of De Moivre's theorem. We have already seen that there are many ways we can solve De Moivre's theorem problems. So in this case, we have to simplify the given equation, that is cos pi by 22 plus I sine divided by 22 to the power 11 cos pi by 21 minus I sine pi by 21 to the power 7 divided by cos pi by 36 plus I sine by 36 to the power 9 and express in a plus ib. So first we have to use the De Moivre's theorem, that is cos. We know that using De Moivre's theorem, cos theta plus I sine theta to the power n is equal to cos n theta plus I sine n theta, where n can be positive, negative or fraction. So here it is cos 11 into pi by 22 plus I sine 11 into pi by 22. Next is cos 7 into pi by 21 minus I sine 7 into pi by 21 divided by cos 9 into pi by 36 plus I sine 9 into pi by 36. 11 twos are, 7 threes are, and 9 fours are. So we have cos pi by 2 plus I sine pi by 2 into cos pi by 3 minus I sine pi by 3 divided by cos pi by 4 plus I sine pi by 4. Now we have to substitute the value of cos pi by 2, sine pi by 2, cos pi by 3, sine pi by 3, cos pi by 4 and sine pi by 4. So we know that cos pi by 2, that is cos 90 degree, is equal to 0. Sine 90 degree or sine pi by 2 is equal to 1. Next, cos pi by 3, that is cos 60 degree. Cos 60 degree is equal to 1 by 2, and sine pi by 3, that is sine 60 degree, is equal to root 3 by 2. And in both the cases, cos pi by 4 and sine pi by 4, sine pi by 4 and cos pi by 4 both are equal, that is 1 by root 2. So we have 0 plus I cos pi by 3, that is 1 by 2, minus I sine pi by 3, that is root 3 by 2, and this term, it goes to numerator, it is 1 by root 2 plus I 1 by root 2 to the power minus 1. Next is I, 2 is common, so 1 by 2, 1 minus root 3i. This is if power I, so it is 1 by root 2 minus I 1 by root 2 of, or if we use it here only, cos pi by 2 plus I sine pi by 2 cos pi by 3 minus I sine pi by 3 cos pi by 4 plus I sine pi by 4 to the power minus 1. So next, cos pi by 2 plus I sine pi by 2. This is cos pi by 3 minus I sine pi by 3. And by using De Moivre's theorem, this is cos minus of theta is equal to plus theta, so cos pi by 4. Sine minus of theta is equal to minus sine theta, so minus sine pi by 4. So in the cos pi by 2 is equal to 0 plus I sine pi by 2 is equal to 1. Cos pi by 3 is equal to 1 by 2. I sine pi by 3 is equal to root 3 by 2 into I. Cos pi by 4 is equal to, and sine pi by 4 both are 1 by root 2. Now next is, this is I first term. If we take 2 as a LCM and taking 2 common, 1 by 2, so it is 1 minus root 3I. Next, 1 by root 2 LCM and taking it as a common, 1 minus I. So it is I 2 root 2, 1 minus root 3I, 1 minus I. Simply multiplying 1 minus I root 3I plus root 3I square. So I divided by 2 root 2, 1 minus I root 3I. I square is equal to minus 1, that is root 3. Now next is to multiply with I. So it is 1 by 2 root 2 I square minus root 3 I square minus root 3 I. So it will be 2 root 2 I square is equal to minus 1 minus minus plus 1. Again it is plus minus 1 minus minus plus minus root 3 I. So it is 1 by 2 root 2, 1 plus root 3 plus I common 1 minus root 3. So it is the final result of, or we can write it as 1 plus root 3 divided by 2 root 2 plus 1 minus root 3 divided by 2 root 2 into y. So it is in the form of a plus I, where a is equal to 1 plus root 3 divided by 2 root 2 and b is equal to 1 minus root 3 divided by 2 root 2. The second problem is, if x plus iy is equal to 3 divided by 2 plus cos theta plus I sin theta, then prove that x minus 1 into x minus 3 plus y square is equal to 0. For that, we have to first find out the value of x and value of y. So given x plus iy is equal to 3 divided by 2 plus cos theta plus I sin theta, multiplying numerator and denominator, that is rationalizing the above term I sin theta divided by 2 plus cos theta minus I sin theta. So that will be equal to 3 times 2 plus cos theta minus I sin theta divided by a plus b into a minus b is equal to 2a square plus b square, that is 2 cos theta minus I sin theta square. I square. So is 6 plus 3 cos theta minus 3I sin theta divided by a plus b whole square, that is 4 plus cos square theta plus 2 into 2 4 cos theta. I square is equal to minus 1 minus minus plus, that is plus sin square theta. We know that cos square theta plus sin square theta is equal to 1, and 1 plus 4 is equal to 5. So in the next step, 6 plus 3 cos theta minus 3I sin theta divided by 5 plus 4 cos theta. So this term can be written as 6 plus 3 cos theta divided by 5 plus 4 cos theta minus or plus I times minus 3 sin theta divided by 5 plus 4 cos theta. This x plus iy. So equating imaginary and real and imaginary part, equating real and imaginary parts on both sides. The value of x is equal to 6 plus 3 cos theta divided by 5 plus 4 cos theta, and value of y is equal to minus 3 sin theta divided by 5 plus 4 cos theta. Now in the next we have to find the value of x minus 1, then x minus 3 and y square. So x minus 1. So x minus 1 is equal to 6 plus 3 cos theta divided by 5 plus 4 cos theta minus 1. So it is 6 plus 3 cos theta minus 5 minus 4 cos theta divided by 5 plus 4 cos theta. So it will be 6 minus 5 is equal to 1, and 3 cos theta minus 4, that is minus of cos theta divided by 5 plus 4 cos theta. X minus 3, so it is 6 plus 3 cos theta divided by 5 plus 4 cos theta. So minus 3, so it is 6 plus 3 cos theta minus 15 minus 12 cos theta divided by 5 plus 4 cos theta. So it will be equal to 6 minus 5, 15, that is minus 9, and 12 minus 3, that is minus 9 cos theta divided by 5 plus 4 cos theta. So we have to use the LHS term. LHS x minus 1, x minus 3 plus y square. So x minus 1 is 1 minus cos theta divided by 5 plus 4 cos theta. X minus 3 is equal to minus 9 cos theta divided by 5 plus 4 cos theta. And y square, the value of y is minus 3, it is 9 sin square theta divided by 5 plus 4 cos theta whole square. So multiplying the first two terms, 5 plus cos 4 cos theta square, this is 1 minus cos theta. If we take minus 9 common, so it is 1 plus cos theta. Plus 9 sin square theta divided by 5 plus 4 cos theta whole square. So LCM is plus 4 cos theta whole square minus 9 a plus b into a minus b, it is 1 minus a square minus b square, that is 1 square is equal to 1, so 1 minus cos square theta plus 9 sin square theta. So we have minus 9 plus 9 cos square theta plus 9 sin square theta divided by 5 plus 4 cos theta whole square. So 9 cos square theta, 9 sin square theta, so minus 9 plus 9 common cos square theta plus sin square theta divided by 5 plus 4 cos theta square. Cos square theta plus sin square theta is equal to 1, so it is 9 into 1 is equal to 9. 9 minus 9 is equal to 0. Divided by this is equal to 0, is equal to RHS. Or we can simply write 1 minus cos square theta is equal to sin square theta. So minus sin square theta plus sin square theta is equal to 0. 0 divided by 5 plus 4 cos square theta is equal to 0. So LHS is equal to RHS, verified or proved. For solving the next part of the problems of De Moivre's theorem, we have to first revise the general form of De Moivre's theorem. So we know that x plus iy is equal to, can be written as r cos theta plus I sin theta, where x is equal to r cos theta and y is equal to r sin theta. So in the general form, this equation can be written as, in place of theta it is 2n pi plus theta, and in place of sin theta it is sin 2n pi plus theta. So the problem is next, number 1. In this series problem, solve x to the power 12 is equal to 1. X to the power 12 is equal to 1. So x to the power 12, that means 1. This 1 can be written as 1 plus I into 0. So we have to find the value of theta. For that, the value of cos is equal to 1 and the value of sin is equal to 0. So it is cos 0 degree is equal to 1, sin 0 degree is equal to 0. So here the value of theta is equal to 1. Sorry, 0. Value of theta is equal to 0. Also we know that the value of r is equal to root over x square plus y square. So if we compare this equation with this or with this, x plus y or 1 plus I into 0, the value of x is equal to 1, the value of y is equal to 0. So r is equal to root over 1 square plus 0 square, that is equal to 1. So other equation can be written as, in the form of this general form, the value of r is 1 cos 2n pi plus theta is equal to 0 degree. So 0 plus I times sin 2n pi plus 0. So in the next case it is 2n pi plus I sin 2n pi x to the power 12. So value of x is equal to cos 2n pi plus I sin 2n pi to the power 1 by 12. Now using De Moivre's theorem, that is cos theta plus I sin theta to the power n is equal to cos n theta plus I sin n theta. So here it is cos 2n pi divided by 12 plus I sin 2n pi divided by 12. So solving it is 2 6 are 12, 2 6 are 12, that is cos n pi by 6 plus I sine n pi by 6. In the general case where x plus iy is expressed in terms of r cos 2n pi plus theta plus I sine 2n plus theta, the value of n is equal to 0, 1, 2, 3 and so on. So on putting n is equal to 0, 1, 2, 3 and so on, we can find the required values of x. So it is the solution of x to the power 12 is equal to 1. We have to remember this term, and first we have to find the value of r and then theta, and substituting the general case we can solve easily. The next problem is number 2. X to the power 7 plus 1 is equal to 0. So this can be written as x to the power 7 is equal to minus 1. So minus 1 can be written as minus 1 plus I times 0. So for what value of theta? The value of cos theta is equal to minus 1. So it is cos pi. Cos pi or cos 180 degree. Cos 180 degree is equal to cos 90 plus 90. That is minus sin 90 is equal to minus 1. And sin pi, it is sin 180. So sin 90 plus 90 is equal to plus sin 90 is equal to 0. So we can easily find the value of theta. So theta is equal to pi here. Now next, what is the value of x? X is equal to minus 1, y is equal to 0. So r is equal to x square plus y square. That is minus 1 square is equal to 1, 0 square is equal to 0, that is equal to 1. So x to the power 7 is equal to, the general solution is r times, that is r is equal to 1, cos 2n pi plus pi. The value of theta here is pi plus I sine 2n pi plus pi. Cos 2n plus 1 into pi I sine 2n plus 1 into pi. Therefore x is equal to cos 2n plus 1 pi plus I sine 2n plus 1 into pi to the power 1 by 7. So we have cos 2n plus 1 divided by 7 into pi I sine 2n plus 1 into pi divided by 7. This is the value of x. So next we can write again on putting n is equal to 0, 1, 2, 3, so on, we can find the required values of x. So on the next class or video, we will solve all the problems of above. So for that, in the next video we will solve some problems. These are x to the power 5 plus 1 is equal to 0. Number 4, number 4, 1 plus I to the power 1 plus I to the power 1 by 3. Number 5, root 3 plus I to the power 1 by 6. So these three problems are solved in the next